Assalamualaikum and greetings to all. My name is Khairina from the Mechanical Precision Engineering Department under the ICOSA of IMAS with Dr. Nuhas Nidawani as my supervisor. My study is on nanocoating for anti-corrosion in marine application. So, corrosion has become one of the outstanding problems in the marine industry. This marine corrosion refers to the breakdown or degradation of metallic materials due to an electrochemical reaction when the surrounding environment, for example ocean, lake or sea, contains a naturally high salt moisture content. Recent industrial catastrophes have it that many industries have doomed several billions of dollars due to corrosion, and 90% of ships' failure are attributed to corrosion. And to repair the coatings offshore, it can be up to 100 times the cost of the initial coating, and the NACE International estimates that the total cost of marine corrosion worldwide is between $50 to $80 billion every year. Wow, that is a lot of money just to repair a ship. And to prevent these corrosion problems, a marine coating has been developed and used to protect ships, vessels, tankers, and other materials. It has specific functional properties, therefore it can protect materials from corrosion and abrasion. A ship hull's coating system consists of a primer which has anti-corrosion properties, then an antifouling coating which provides a transition from the primer to the antifouling coat which bonds generically different types of coatings, and lastly, the top coat or the finishing coat. So this antifouling is the process of removing or preventing the accumulation of marine organisms from the surface of hull, and the paint used for this application is called antifouling paint. However, the marine coating nowadays consists of chemicals that are toxic to marine organisms. Tributylene, TBT, it prevents the growth of algae, barnacles, and other marine organisms. TBT is a biocide which came into being in the 1970s because of its brilliant antifouling properties over ships' hulls, as it prevents the growth of these organisms. But it also cause disruption of endocrine system of marine shellfish, and also it impairs the immune system of organisms and malformations of the shell of the shellfish. For example, here are the killing mechanism of TBT based antifouling coating through their toxic effects. And also, it has been banned by IMO on 2008 due to these reasons. But nanotechnology could also help solve the issue of marine biofouling by creating coatings that are adapted to provide no purchase for wildlife on ship hulls without releasing harmful copper into the environment through nanocoating. Nanocoating is a thin films that apply to surface and layers to achieve vast range of functionalities. For example, this anti-fouling, anti-corrosion, anti-icing, and also the self-cleaning. And the nanocoating is super hydrophobic. Well, the definition of superhydrophobic is the repelling water to the degree that water droplet cannot be flattened but roll instead. Interestingly, the superhydrophobic coating can effectively prevent corrosion, credited to the presence of air pocket existed between surface and corrosion solution, and these pockets act like a barrier and prevent from corrosive ions diffusion and protect the substrate. So my objective is to develop a coating for corrosion protection in marine applications. Next is to test the mechanical durability of the nanocoating. And lastly is to investigate the corrosion protection by comparing the nanocoating that I will fabricate and the marine paint. As for the research in this nanocoating area has been increased the attention from all over the world. A research by Ayman Atta et al. Has captured my attention on seawater absorption and adhesion properties. In this research stated that epoxy coating has been preferred for the protection of steel from corrosion in seawater. And the nanomaterial based in organic oxides, that is zinc oxide, appear to be promising for producing sustainable epoxy coating to decrease the affinity of seawater to disrupt the anti-corrosion performance. And also, this paper regarding the mechanical durability of the nanocoating, either the abrasion or adhesion testing, but I use the method that focusing on abrasion testing for my research. As for methodology, we have prepared a sample of 2.5 times 2.5 times 0.3 of carbon steel. It was cut and grind by using the cutter machine and surface grinder machine, that is Okamoto Grind X, that's available in our precision lab. Until it produced a smooth surface like in the photo. It was then cleaned by using ethanol solution and rinsed using deionized water, DI water. And then I fabricate the zinc oxide epoxy superhydrophobic coating in the EMAS lab. However, due to MCO, the pandemic, we couldn't do more experiments. So what we could do is the measurement of water contact angle, the abrasion testing, and the immersion test by visual inspection. We did it at home, like as in work from home. Yeah, but we could do more experiment with more good result. Okay, so as for the nanocoating solution, we use 2.4 gram of zinc oxide nanoparticles and 2.5% of stearic acid that were dispersed in 10 milliliter of ethanol solution with constant agitation of 180 rpm at 55 degrees Celsius for 5 minutes. It was then undergo ultrasonication by using an ultrasonicator probe at 500 watt, 20 kilohertz for 5 minutes with addition of epoxy resin and hardener by the ratio of 2:1 and mechanically stirred for 10 minutes. The coating is then applied to the surface of 2.5 times 2.5 carbon steel and dried at the ambient temperature for 24 hours. So here's the picture of our sample that has been done, but only a few because due to MCO we couldn't continue after Raya. So to measure the characterization of the sample, a contact angle test was made by using the Cecil drop method. As you can see in the photo shown that the result of water contact angle test of and the left side is anti-fouling marine paint, which is 116 degrees, and on the right side is the zinc oxide superhydrophobic coating with 164.427 degrees, where a superhydrophobic characteristic will have to be more than 150 degrees. So, and then it was measured by using ImageJ software. Okay, next, I did some sandpaper abrasion testing with ASTM of D4060, where in the photo shown that the sandpaper with the grade of 80 grit, 800 grit, sorry, and the sample, uh, there will be weight on the sample and it will moving constantly. Okay, so here's the result of sandpaper abrasion test. The zinc oxide epoxy nanocoating A shows no major effect, while the antifouling marine paint shows some scratch at the side of the sample. Next, on the abrasion test, I did a pencil scratch testing with ASTM D3363, where the nanocoating, the zinc oxide epoxy nanocoating, shows no abrasive wear on the surface, even after being cleaned. I'm sorry, but the marine paint surface shows some scratch. And for the immersion test, since we cannot enter the lab, it was supposed to have the potential stat to measure the immersion test, but here I just measure by using 5% of sodium chloride in ACl solution for 24 hours. It's shown that after the immersion test, there will be like slightly colored from the antifouling marine paint. Sorry. Okay, so with that, that is my presentation. Thank you for listening.